So you've got 2 to the power of 2x plus 2 to the power of x minus 6 equals 0. So what's the first thing you did?
2x all squared.
Okay, so you wrote that as 2 to the power of x all squared plus 2 to the power of x. Good?
Then m equals 2x.
Okay, so u equal 2 to the power of x. Good?
M squared plus m minus 6
Yep.
0.
Equals 0. Perfect.
M plus 3 and m minus 2.
Yeah, I agree with that. So what do you get as
M equals -3 and m equals plus 2.
good? Okay. So far so good. So the issue occurred when you put your u, or your m, whatever you call it, back in, so the 2 to the power of x. As you get 2 to the power of x equals -3, 2 to the power of x equals 2. So can you just tell me what logarithm you wrote down? So x equals...
Log 2 -3.
Yep.
And log 2 2.
Okay, so x equals log to the base 2 of 2. Okay. Now, when you stuck this one in, so can you just quickly just do this one, did you get an answer?
1.
Okay, you just got 1. Perfect. It's 2 to the power of what gives you 2? It's obviously got to be 1. Okay. Now, you said when you stuck this one into your calculator, it came back as an error. But that's kind of to be expected, isn't it? Because look what's happening. You're taking log to the base 2 of a negative number. Do you remember last week when we were talking through our logarithms? You have to always be able to take the logarithm of a positive number. The reason being is because logarithms are just the reverse of exponentials. So if I draw in my exponential graph, I don't know, let's suppose it looks like this. So this would be like y equals 2 to the power of x, okay? Well, my logarithm graph is just a reflection in the line y equals x, because my x and y axis has to swap over. They're inverses. So this is what my logarithm graph would look like, okay? So my logarithm graph would look like this. This would be y equals log to the base 2 of x, okay? So that's what my logarithm graph would look like. So let's think about the possible values that you can put into your exponential graph. What values of x can you put into your exponential graph?
0, 1, 2.
Yeah, exactly. You can put any value in. Yeah, because you can also put negative ones in or positive ones. You can basically put any value for the power up here you like. So we call this our domain. It's basically the set of input values. So in this case, x can be any real number you like. Okay. What about our range? What is the set of output values that we get out? So looking at this graph, what's the set of output values?
For x,
For y.
more than 0.
Exactly, it's got to be, strictly speaking, greater than 0, but not 0, because that's an asymptote. So in other words, our output values have got to be greater than 0. Now, whatever happens, because these two things are inverse of each other, our domains and ranges effectively swap over, because all of our x values become y values and y values become x values, right? So in this case, our domain for our logarithm graph, can you see it's basically you can stick in any x value as long as it's positive. Do you see that? Because our range of this graph was our y is greater than 0, which means the domain has got to be x, has got to be greater than 0. And you can see that from the graph. You can only stick in positive values of x to our logarithm, okay? And our range, well, our range has no restriction. Our range can be any real number you like, okay? Basically get any value out. So, the moral of the story is if you're taking the logarithm of something, that something has got to be positive. Which is the reason why when you stuck this in your calculator, it didn't work. Does that make sense? Because you're trying to take the logarithm of something which is negative. So we just simply write down here, there are no real solutions for this graph, okay? And if you remember when we did our logarithms last week, we kind of said, well, this is the last little step. Once you've done your logarithm, solving your logarithm equations, yeah, you have to check that the value that you actually get at the end is valid. And the way you check it's valid is that it's got to be strictly positive, okay? So yeah, it's good that you kind of got that in your calculator going, there's something wrong here. But if you just think about it, that's completely to be expected. Is that okay? Is that clear? Good. Okay, let's have a look at this question then. Okay, could you have a look? So we'll have a look at this one together. Let's have a look at 2 times by 4 to the power of x plus 3 times 4 to the negative x equals 7. Okay, so let's have a look at this one. I'll tell you what, I'll do it on the board and then I'll give you an opportunity to write it down so we can just follow along, okay? Okay, so have a look at this. Does this follow our kind of hidden quadratic properties? In other words, is this power double what this power is? No, it's not, because if this was double, it would be negative 2x, wouldn't it? So, look, I don't know how to solve it at the moment, okay? But let's have a think. 4 to the power of negative x. Could I write that in a way without the negative power? So I'll keep this the same.
Negative 4x.
It wouldn't be negative 4 to the power of x, no. Can you remember what happens if you have a base raised to a negative power? If you want to write that as a base raised to a positive power, remember you have to reciprocate it. So if I have 4 to the power of negative x, that should be the same as 1 over 4 to the power of x, okay? Good, so that's just laws of indices, right? Okay, fine. So I've got 4 to the power of x there. Even though I know it doesn't follow a quadratic equation just yet, I'm still going to let my u or m or whatever I want to let it equal. I'm still going to let it go for I'm still going to let it go for 4 to the power of x. I think that might make a bit more sense. So if I let u equal 4 to the power of x, I get 2 times by u. That's fine. Plus, we'll have a look here. I get 3 times by 1 over 4 to the power of x. I know my 4 to the power of x is just u. So it'll be 3 over u. Does that make sense, that thing there? Yep. And that equals 7. Okay. Anything I could do here?
Bring the 7 inside.
Sorry?
Bring the 7 inside.
Okay, so bring the 7 on the other side. I agree with that. So 2u plus 3 over u minus 7 equals 0. Yep.
Do we do by the
This is the issue, isn't it? Multiply by u. Exactly. This is the issue. The 3 divided by u. Don't like that divided by u. That's fine. Just multiply by u. Only caveat is I've got to multiply every single term by u. So that's a common mistake which people make. They don't remember to multiply every term by u. So what's 2u multiplied by u?
2u squared.
Oops, yep. What's 3 over u multiplied by u?
3u.
Just 3, isn't it? Because you get 3u divided by u, which is just times by u divided by u cancel, so just get 3. Yep. What's 7 multiplied by u?
7u.
And what's 0 multiplied by u?
0.
0. Okay. Well, look, if I just swap these two terms over, so 2u squared minus 7u plus 3 equals 0, that's a quadratic, isn't it? Could you have a go at trying to factorise that for me? So do you want to write down what we've got up to up there, and do you want to have a go at factorising that for me? Okay, so before you stick that in your calculator, just tell me what you factorise this to, please.
2u squared minus u minus 6u plus 3 equals 0.
Okay, so could you just tell me the two brackets that you factorised it to, so rather than going through the method?
U minus 3
Yep.
and 2u minus 1.
Okay, I agree with that. Good. So therefore you get u equals a half, or u.
Equals 3.
Perfect. But of course we don't want u, we want 4 to the power of x. So I'll write it over here. So we have 4 to the power of x equals a half, or 4 to the power of x equals 3. So x will be log to the base 4 of a half, or x equals log to the base 4 of 3. Okay, so what numbers did you get in your calculator then?
For 3, 0.79. And for the half, negative half.
Negative 1 over 2. Good. Is that okay? Yeah. So, yeah, it's just about keeping your wits about you, in all honesty. So when you kind of get to here, don't just give up because it's not kind of falling out like the other questions. Kind of keep with it and go, well, okay, at the moment I can't see where it's going to go, but I'm just going to make my substitution. Because if nothing else, that means that I'm working with u's instead of 4 to the power of x's, which to my mind looks nicer. That looks nicer than that. And then you just kind of figure out and say, well, okay, if this was an ordinary equation, well, I'd multiply both sides by u. I end up with a quadratic. Hey, I'm in business.